thank you everyone for joining the fourth day of the RDA Global Adoption Week. My name is Timea Bairo. I work with the Digital Repository of Ireland, and with my colleague Stephanie Keeters, we'll be moderating today's session entitled Disseminate, Link, and Find of the Adoption Week, which is showcasing RDA adopted and adoptable solution designed to support researchers and practitioners in this fourth phase of the research data lifecycle. Before we get started, I would like to highlight a few housekeeping points. Please note that we are recording this session, and the recording will be made available, publicly available, linked from the RDA website. You are also by default in listen-only mode, so we kindly ask you to use the question box that you have in your GoToWebinar control panel to ask any questions that you might have after each of the presentations. Please make sure you also add your name so we can read that out loud. We will also try to pick up any raised hands if you wish to speak and ask any of the questions. Now, before we get started, we would like to understand a little bit who's in the audience. So we've prepared a very short, with a couple of questions, Slido. If you would like to go to slido.com and type in the code hashtag W339. We would like to understand a little bit about who's in the audience in terms of role, discipline, and we will ask you one additional question to see what is your main interest in joining the session. So already thank you for the answers. Wow, that's a complete breakdown between some of the roles we have outlined. I'll try to go full screen so then you can see all the options that we have available. So we have data practitioners and research support staff. We see some of the policy funders, as policymakers and funders have joined us, librarian and archivists, which is very important. Thank you very much. Project managers and IT and infrastructure specialists. It keeps on balancing out. So there's quite a nice breakdown of the different roles. Not many researchers, although a lot of the work that obviously RDA is doing is focused on the researchers. But we're glad to see so many of the research support staff. I'm going to pass on to the next question. This would be useful to understand also for our speakers, like in terms of the various disciplines, domain agnostic, which a broad spectrum, but we've tried to break it down in terms of social sciences, computer and information sciences, humanities, natural sciences, medical and health. We see a very nice, well, the half of the audience that is not domain agnostic. There's a nice breakdown. So thank you very much for that. The presentations today are quite domain agnostic, so we hope that everyone will pick the relevant points for their specific discipline and cross or multidisciplinary approach. The final question, we would just like to understand what is the issue or the question that has brought you to our session today, which might be related to a specific topic of the presentations today, or maybe in general the RDA outputs. So if there's anything else, anything specific that you'd like to learn today, by all means, it is an open-ended question, and we'll leave it on for later on as well. It might be interesting to for our speakers know in advance, because maybe they can focus some of the things that they will address in their presentations on the topics that you have highlighted. So we have data discovery. Someone is very much interested in Ming's work, so that's very good, because she's the first one to start today. Implementation of fair metrics. Again, we're going to leave the poll open, so if there's anything else that will come to mind during the presentation, you can add it to the question panel in GoToWebinar, or even leave it in the Slido. We'll try to pick up on all of these questions, and if there's anything specific, maybe this can also be taken offline. So best practices, another answer, best practices to measure fairness of research data. Okay, I will leave the poll open, as I mentioned, and we can go back to the presentations. So this is our, I'll try to go full screen if that helps. This is our lineup for this initial session. I'd like to just remind you also that we will have a second session of focused on disseminate, link, and find research data in the data lifecycle based and connected to the RDA adopted and adoptable solution. So as I mentioned, without further ado, our agenda for today features two of the RDA working groups. So the Data Discovery Paradigms Interest Group and the Fair Data Maturity Model Working Group. And we also have an adoption story, which is the third presentation. If you have any questions, again, each of the presentations, so each of the slots will be followed by the Q&A session. So first on the agenda, we have the Data Discovery Paradigm Interest Group, and we have two of the co-chairs with us. If you'd like Ming and Fotis to turn on your cameras briefly, so then people can associate your names with with the presentation itself. So as I mentioned, we have Mingfang Wu from the Australian Research Data Commons, and we have Fotis Psomopoulos from CERTH, who will be presenting two of the outputs from the Data Discovery Paradigms Interest Group. So in the meantime, I'll pass on the presenter roles to Ming. And hopefully this will be smooth. Let's see. Yes, we can see your slides, Ming. Oh,
okay, now in present mode.
Yes, that's very good.
Okay, thank you, Tiama, and hello, everyone. Make it clear, this is not Ming's work. This is work from the Data Discovery Paradigms Interest Group. And so this group started in late 2016. We had about 4 task forces between 2017 to 2018. So I am going to talk about the supporting output from the relevance ranking task force. My co-chair Fotis will talk about supporting output from 2 other task forces in a few minutes. So briefly, what is relevance ranking task force about? So in last decades, we have seen many data repositories appear, and the number of data sets in each data repository has also been increasing. We will see this trend will continue in coming years. With so many data and out there, now it's challenging for discovering data sets. So what data repository do? Just plug in data discovery systems, then have a search box there for users to find data. So the index matching and ranking are important components of this data discovery system. So the relevance ranking task force is a forum for exchanging experience on the deployment or development of index matching and ranking data discovery system. So for a start, we would want to know what data search system and the ranking models have been deployed by repositories, and how we are at for providing such a data discovery system. So we will see have there any evaluation done, so that could be serve as a benchmark to be looked at in future to assess how much and in what way and the data search has improved. We also want to identify potential collaborative projects. So we instrumented the survey with these 3 broader goals. So in that survey, we had 33 questions, cover 6 categories of questions, such as the characteristics of repository, what the configuration of ranking models, and what kind of a query method has been provided, what are evaluation method and a benchmark, what other methods have been used to boost searchability, and also what the wish list for future activities for the task force. So we had good participation. We had 98 repositories responded to the survey. The participants are mostly from North Americans and from Europe, and a few from Australia, Japan, and China. And those repositories also cover different domains. We have a spread of domains, but a few domains like life sciences, science, and social science are most covered. So I would refer you to the survey report for details. Here I just shown some highlights. So those participant repositories basically deployed similar search system, mostly Elasticsearch, Solr, and Lucini. Solr and Elastic also build on the Lucini library, but they provide a facet search. So in terms of what mode this, no matter Elastic, Solr, or Lucini, and underneath there are several ranking models. So half of participants didn't know what are the ranking models they used, and for those who know, it varies. So Lucini library is mostly used for text search, so how to configure that library to fit the dataset search is a big question. So which models here would be good for data search? That's a question to explore. And the reason for choose such a system is unsurprisingly the popular reason is because they have available expertise and skills in-house, and also the support and open source also important factors for choosing such a system. So in terms of benchmark of those discovery systems, so majority of the repositories didn't conduct any kind of evaluation, and about a quarter of them conducted different kind of evaluations. Some did a log analysis, some did informal evaluation, just to send a query and a local result. And none of them, that's good ones, they create test corrections. And yet on the right diagram, you will see half of those repositories, they are confident their search engines will satisfy most users. And even majority of them didn't conduct any evaluation. So in summary, what the takeaway message is for us? So we see in last decades, we rushed to getting discovery systems deployed and make data searchable by users, but repositories desire guidelines how to improve relevance ranking, especially those small repositories. They don't have a resource and have the great needs for such a guideline. And then secondly, a repository understands and the evaluation of discovery system is important. Again, here, because of lack of resources and expertise are the reason not able to do such evaluation. So these together may be opportunities for data community also collaborate with other technology communities and the library and the information science community, for example, to work together, build test collections, and to see the search system to be improved in future. Okay, that's all from me. Now I will pass on to my co-chair, Fotis, to introduce supporting output from two other task forces.
Right, hi everyone. I hope that you are able to see my screen. So let me make this in present mode now. Right, so I'm following up directly from Mingfang's excellent presentation. As Timea said earlier, I'm the co-chair of the Data Discovery Paradigms Interest Group, and I want to present two more outcomes of the same group. Just to put things in context and to sort of highlight what is the relevance to these particular outcomes. So the motivation of the Data Discovery Paradigms Interest Group is essentially how to make research data findable for the end users in mind, but adhering to and aiming for all the different stakeholders in the data discovery process. Sorry, too fast. So in order to achieve that, these interest groups sort of provide a forum where we have multiple people from different backgrounds and different expertise and experiences to sort of exchange ideas on how to improve this data discovery process. And the key outcome is how to produce these actionable recommendations. And this is what I want to present now. So the first output is a very specific one. It's essentially 11 quick tips for finding research data. And these practices are basically aimed for the data seeker and can be used both for learning and also to provide training for research skills. And in short, these are the 11 tips. I'll go through a few of them just to make some quick points, but I would definitely encourage you to look into the actual publication. It's published on PLOS Computational Biology. So as well as linked on the RDA output page. So out of those 9 points, some that are practical, some may say self-evident, but it's also important to highlight. So the first thing is, the first tip is how to think about the data, what you need and why you need them. When you figure out this actual process, you will easily facilitate the next step. So you can find what is the appropriate resource, and also try to construct the query you submit strategically, so that you actually retrieve the information you're looking for. The fourth point is to make the repository work for you, which also implies that you have a better understanding of how the repositories work, and then you can refine your search to accommodate for the extra characteristics that a repository might have, because a repository in life science may have completely different characteristics from a repository located in climate sciences. Being able to assess the data relevance and save the search can help also review the information you retrieve at a later stage. And moving beyond the actual search, there are some good points about identifying also about data services. So when you're looking for data, it might be also relevant to look at other corresponding data services that can provide access to data. So this means looking for APIs or looking for other types of services that are not traditional look and search repositories. The final point is to talk about the sensitivity of data. So when you're dealing with sensitive data, which is usually a more prominent issue in life sciences, you have to treat them responsibly, which means adhering with any other requirements that go with that. And also, talking for researchers, give back, which means you should be able to share data and as well as cite the data itself. So going for the second output, this was moving away from the seeker, but focusing a lot on the data repositories themselves. We have two set of guidelines, if you like. So the one are some requirements, and in order to achieve these requirements, we reached out and got information from people who are actually using data repositories on what they expect from these data repositories. So these are the 9 requirements that have been captured through sort of interviews with people, surveys, and trying to capture all different stakeholders, from researchers, librarians, policymakers, founders as well. And these requirements can be used from the data repository operators as a checklist when they are providing a data service portal, what to do, what to implement. And for the existing data discovery services, what are the guidelines that you can ensure that you can improve your services? And those are in all-time high, especially given the context of big data. Complementing those requirements from them that have been retrieved from the user surveys, we also have the recommendations that can be directly applied to data repositories. And these recommendations are more practical in the sense of how you can support multiple query interfaces, how you can have multiple access points so that you can support different users. All those, how to have available bibliographic references so that people can easily cite them. So all those aspects have been retrieved from these user surveys and crystallized into concise, practical approaches that can be implemented by different repositories. In closing, and this is the corresponding publication of the output, we did a mapping between these requirements and recommendations, and how its recommendation that we submit as appropriate for data repositories can be aligned to the different requirements that the users themselves offer through this user service. And you can see that there is a nice match between the two. Some of them are more cross-cutting. So the first 8 are connected a lot to 10 single rules for finding data. Some else are connected with the FAIR data principles, which are more encompassing. But all in all, they are a very good approach to connect those things together and ensure that data services offered by data repositories and facilitate and improve the experience of users and data seekers. And with that, I'll thank you, and I also thank my co-chairs for that. And I give the floor back to Timea, I think.
That's okay. Yes, thank you very much. You can leave that slide on. Let's see if there are any. Oh, it's okay. It's okay. Don't worry. Let's see if we have any questions. Again, please feel free to use the question panel in your control box, the question box in your control panel to ask any questions that you might have for our speakers. Thank you very much, Ming and Fotis. In the meantime, if anyone is interested, how can, apart from your private emails, they can also join your group if they have any questions or push forward the debate on that. I see there are no questions, but if you do have any that are related to this first set of presentations, please feel free to type them in at any time, and we'll try to address them also at the end of the webinar. So I'll try to pass on then to our second or third speaker today, but for our second slot on the agenda. So Keith Russell, he comes from the Australian Research Data Commons, and he's going to talk to us about the FAIR data maturity model. So I will make you presenter. Let us know if you can share your slide deck and also your camera if you would like to say hello, Kate. Okay, we can see the slide deck.
Excellent. There we are.
You should go in presentation mode because now it's in.
Yes, indeed. No, okay, so you can see my slide, and that's wonderful. We'll now go to presentation mode. There we are.
Yes, that's perfect.
Excellent.
Okay,
great.
Thank you very much.
Okay, well, you've gotten a brief glimpse. I will turn the video off again for those for whom bandwidth issues might be a problem. So I will, yep, there we are. That's my video off. Okay, so my name's Keith Russell. I work at the Australian Research Data Commons, but I'm here to speak as a co-chair of the FAIR Data Maturity Model Working Group. So I'm one of the three co-chairs, together with Edith Herzog and Shelley Stahl. And in this working group, we've also been supported by an excellent team from PricewaterhouseCoopers, which has done a wonderful job. And without them, we wouldn't have been able to achieve as much as we did in the 18 months we've been around for. So what I'll be talking about today is the main output that we aim to deliver. So the thinking behind the working group is that when the FAIR data principles first emerged, they received a lot of recognition, a lot of uptake internationally, but also quite a wide variety of translations and interpretations of what the FAIR data principles meant exactly. And there were also a number of different FAIR self-assessment or FAIR assessment frameworks that were developed in different places around the world. And I sort of said, well, it'd actually be useful to bring those together and see if we can come up with a shared agreement around what an assessment of the fairness of data would actually look like and what should be included in that. So the approach we took to do that was to reach out around the globe and bring together a whole range of different stakeholders and bring together those existing approaches and come up with a shared set of indicators, what FAIR would look like, with alongside those indicators, assessment of how important each of those indicators were. So that resulted in our final final specification and guidelines, which we came up with a sort of a community agreed one, which we then put up for another stage round of community review. That resulted in a further 14 comments. Those have been incorporated. And now the sort of final version has gone to the RDA Council for endorsement or approval. So it's just about done, and it's available on the website. You can find the link there at the bottom. And to give you an idea of what it looks like, so first of all, it's a large paper document which describes the indicators and their relative importance. But alongside that paper document, we have also provided an Excel sheet which you can actually fill in yourself. So you can take your own data set and fill in how you think you score for a number of these indicators. and it actually also automatically generates a nice spider graph. So it gives you a bit of an idea how you are going on the fairness of your data. So that's a quick theoretical way you could use it, but we've already had 2 adoption examples, and I will speak very briefly of one of these. The other adoption example will be speaking in not in this session, but in a later session today. So first one I'd like to speak about is an example from Jipeng. Jipeng works at the at NOAA, the National Oceanic and Atmospheric Administration in the US, and at the NCEI, the National Center for Environmental Information in the US. So what they decided to do with these fair data maturity indicators that we developed was to hold them up against the data that they had at a subset of data that they had at NCEI. So they're called one-stop ready data sets, and they had already done some work on those one-stop ready data sets, and had already come up with a bit of a framework around that. But they were interested to see how that would compare if they'd hold up the fair maturity model indicators against that. So they did that, and they found it was actually really helpful and very useful. For one thing, they saw that this model that they developed themselves, this data stewardship maturity matrix, already covered quite a lot of things. It also covered a much broader range of archival aspects. But it did also highlight there was one gap, one thing that they currently had not yet addressed, and that is the fact that although the data was open, there were actually no clear licenses around that, and licenses were not included alongside the data. So that was a big lesson that they took out of this exercise of you adopting this output. So they're going to actually take this forward, and on the one hand, they're going to look at the data they already have at NCEI, and make sure that from now on, they will explicitly include a data usage license like a CC BY license, and they're working on that side of things. They're also looking whether they could extend this exercise to more data that they hold, and not just the subset they looked at initially, but at a much wider range of data sets that they hold at NCEI. And if anybody's interested in joining in a discussion around that on the 13th of July, I'm sure these slides will be shared after this presentation, so you can find it there. The other adoption story, which I won't be talking about today, is FAIR's FAIR. FAIR's FAIR has also taken up the recommendations that we developed and has folded that into some of their thinking around what would a fair maturity assessment look like, and what would a repository assessment look like, and how would the assessment of a data set and how would the assessment of a repository come together, and how could those two be brought together in a meaningful way. So for us, the working group has just about come to an end. We will continue though, because these indicators and the guidelines that go alongside this will probably need revision and some critical looking at. So we will continue to exist, and we will be open to reaching out to communities, hearing how they're getting on, making sure that it gets adopted, and seeing if we can build on this on the experiences we've done we've developed in this last 18 months. So that's my brief overview, and I hope that was helpful in getting a view of what the working group has delivered. Thank you.
Yes, thank you very much, Keith. There's been a little bit of a fluctuation in your audio, but I do hope that it was still good enough for the attendees and also for the recording. If there are any specific questions, we welcome them at this point for Keith. If not, again, if you have any questions or further debates that you'd like to have with our speakers. You can join their groups on the RDA website. There is a mailing list associated to that, so we encourage that sort of conversations and exchanges as well. And if there's anything else more specific on the adoption, you can always contact the RDA Secretariat at inquiries@rd-alliance.org. So all the contact details will be made available, of course, and the recording as well as the presentations after our sessions today. So I see there are no questions for you either, Keith.
Okay. Yeah.
So we'll pass on to our next speaker. I will make our speaker a presenter, and you can also see his video. So I'd like to introduce Mohammad Akhlaghi. He is from the Institute of Astrophysics in the Canary Islands, and he's gonna speak to us about what we call an adoption story. And in this case, it's an adoption of the workflows for the research data publishing, models, and the key components. But I'll let him detail more about their work on the adoption case. So here's to you, Mohammad. Thank you. You are muted.
Okay, thank you. Okay, so thank you very much, everyone. Thank you very much, Tima, and thank you very much, everyone, for coming. So I'll just start this talk about adopting one of the RDA recommendations. I'll just stop the video here and go on to the talk. Okay, so in this talk we'll be reviewing an adoption of one of the recommendations of RDA, the publishing data workflows, the outputs of the publishing data workflows working group, which was in combination with the World Data System and RDA. In contrast to the previous two talks, it's going to be more from the researcher point of view. As I'm a researcher myself, I'm in the Astrophysics Institute here, and all of these were developed as part of an effort to make our own science more accurate. And during this period, I was following RDA's outputs and learned a lot from them. And it was great news that ultimately we were able to get this supportive adoption grant to be able to continue working on it. So just as a fast summary, the relevant outputs of the publishing data workflows outputs are the challenges that they mention are as you see, bi-directional linking, how to link data and publications, how to manage the software, because every project needs a whole group of high-level software, and managing them for the repositories to be able to make them more fair is a big challenge. And the matrix and the incentives to researchers to convince researchers to do this. And in the end, they make a really nice conclusion that we would like to see a workflow that results in scholarly objects being connected to enable reproducible research, and this includes linkages between documentation, code, data, journal articles in an integrated environment. So this is effectively what we've been doing, a summary of what we've been doing, so let me go immediately to some more details. So this is the general outline when a researcher wants to do their research. This is what they think, right? I have my software, I have my data, and then I build my software or download them, and I run the software on the data, and I have my paper, and everyone goes celebrating. There are so many questions that come up in this path. What was the version of the software? How was the software configured? What database did the data come from? What version of the data release were they related to? Are the integrity of the data checked? Regarding running of software on data, how were they run, the details of how they were run and everything. And finally, the paper, as mentioned in the RDA outputs, there's many questions that need to be answered. and be able to link the paper with the analysis, with the software, with the data. So yeah, but answering all of these will make every paper like 50 pages, right? So it's not really effectively possible for a researcher to be able to properly answer all of these and have a sufficiently lengthy paper. But without it, well, as a scientist, when I read a paper that doesn't answer these, these low-level questions, I can't really trust the result, right? Like, well, as an astrophysicist, like someone publishes a paper saying galaxies evolve like this, but when I don't know the version of the software and so on, how can I trust that? So yeah, so well, not trust. How can I trust the result? I know they've done a good job, but I can't repeat it myself. So the founding criteria for the solution that we're proposing here, it's been developed over almost 5 years now, mostly as a the internal research side parallel side research for us. But then in the last year with the RDA support, it actually grew a lot. So the basic idea is that science is defined by its method, not its result. So yeah, then we have the scientific method that actually defines science for us. We don't have a scientific result, we have a scientific method. So to be able to implement all of these, well, we set up a set of principles. So like one is that a system that answers these problems should not have any dependencies. It shouldn't require administrator privileges. It should be modular, and it should be all in plain text. So like these special formats, that binary formats that require special workflow formats, that require a special software to open, that is a big incompleteness, because that software will get depreciated in a few years, especially if it's not free software. It's going to be depreciated, and the workflow and everything that's been done with it is going to go away with it. And it should be really simple to implement, because scientists that develop all of these data, they haven't, as much as we'd like, they haven't had a very high level understanding of data carpentry and how to analyze it. So it should be really as applicable as possible, with minimal complexity. And the inputs and outputs should be verified, and it should only use free and open source software. And well, this is obvious, because if it's not free software, then I would argue it's not reproducible. Because yeah, just having a vendor in between it really is a big weak point for any analysis. Okay, so let's have a fast look at all the steps that we've done to do this, to achieve these goals. So first, let's have a look at the first part of this cycle, how the software is managed. So a research project involves many software, and as we said, the whole project has to be stored in plain text, so it can be parsed, by automatic engines in data repositories or in publications, or searched easily. So over here, I'm just showing one plain text file, and you can see the versions of some of the software, like a version of Python, a version of like AstroPy or GNU Astro, some astronomy software, but there's many non-astronomy software too, and we're growing so into larger communities. So effectively, it builds the whole software environment. It has the instructions to build the whole software environment within it. So for example, and this can be really complicated, like this is the dependency tree. Each one of these boxes you see here, you don't have to read them, is one software. And this is matplotlib. It's the Python plotting library, which is very, very common these days in sciences. And just look at how many dependencies it has and how they're interlinked. Managing this is like a repository's nightmare. And well, there are package managers for it, but just imagine if one of these boxes changes its version, something in your plot is going to change. So it's really hard to keep track of all of these things. That's why we build everything from scratch in this system, which we call Maneage, managing data lineage, and Maneage, let's say. So it builds everything that from the core C compiler and up. It builds its full environment. It has all the instructions in a machine actionable way that is both, well, human readable, computer parsable, and machine actionable at the same time. and it doesn't require root permissions. So when you're going on a large server from a researcher point of view, you don't need to, spend 1 week interacting with the administrator of the computer. And for the data repository, they don't need to worry about, viruses or things because it doesn't need root access. And yeah, the installation instructions for all the software in plain text. And another side effect is that because we control the building of all the software, this is one example paper from that uses this that uses Maneage. Looks, you see this whole paragraph here that it's highlighted in green? This is the name of every and version and citation of every single software that was used in this analysis, and it's automatically created as a LaTeX macro that researchers can use in their paper. Just look, this is a full list. Now this project used a lot of software, you can see. But it gives it automatically full list and automatically cites all the necessary software. Okay, for the data, well, this is a big issue because I'm a software, I'm a scientist that does software development myself, and without software citation, projects can't, software projects, research software projects can't evolve really as well. About the data, how do we deal with data? So for every project has this special file, inputs.mk, which we call it, and it has the URL, the full URL you see here, like this. This is from one of my papers, and you see it has the full URL, the MD5 checksum to check the integrity of the data, and yeah, all the necessary information for each data set is included in the project as another plain text file. So you see over here, I'm highlighting them, and this is from this paper, this archive paper. And finally, how we do the analysis. So this is the main part that the project gets its name. It's fully in, again, plain text. It's not a visual workflow system that is well, complicated to manage, complicated to maintain, not manage, because yeah, graphics environments change all the time. So, but this is plain text. This is the same kind of plain text that was done in the 1970s, right? It's it's going to stay because the core operating system of all computers effectively is using this system right now. And yeah, unless we have a revolution in computer technologies, this system is not going to change. So it's going to allow researchers and the data repositories to be able to have a fixed structure. So the system is designed in Make. It's a special framework for workflow management, which is mostly used by the operating system to build all its components. And that's why we chose it, because it's available everywhere. It's available on any computer and can run, because it's actually used to build software environments, researchers at least have already heard of it, and it's been developed for 40 years. And it's being developed and it's being improved, while it can still run code that was like 40 years old. So it's a really strong framework, and that's why we chose it instead of making a new language. We already have many workflow languages around, but we decided to just stick to Make. And in fact, this was one of the suggested frameworks by the pioneers of reproducible research back in the 1990s. Okay, so this is how Make works. Look, you define a set of prerequisites, and then you go from the prerequisites, and you see these steps actually create a link, and then these steps, you just actually make a nice chain of events based on the prerequisites of files. And finally, the paper. So over here, you can see one snapshot of the PDF paper, this PDF paper from my 2015 paper. And like, this is one paragraph of that paper. You don't have to worry about its contents. And this is the LaTeX source that generated this paper. Now look here, you see these three numbers? These three numbers are actually LaTeX macros. They weren't handwritten in the PDF. And they actually all come from this single plain text file. Everything is in plain text. This simple plain text file. And this plain text file is automatically created. So if I just change one parameter in the analysis, I don't have to go manually updating every number in my PDF. They're all going to be automatically updated. And this actually greatly improves the integrity. So just as a fast, show of this system, we'll just reproduce this nice plot by the team of Mingfang et al. 2020, and this is the DOI. So what they did was actually to study how many research papers in biological studies actually mentioned the name of the software tools that they use. So they actually show that, look, the green line mostly. that the fraction of papers mentioning software is nicely increasing. So we got the data set and we tried to reproduce it. And well, it was easy, you can see here. And we also found out that, look, they'd actually gone far beyond the initial review, the published numbers. They actually looked until 1986. But yeah, in the end, they just published from 1997. And now you can see why, because we also put the number of papers that they studied. Okay, so let's have a look at how this is done in Maneage. So it's done with Make, this Make system. Now I'm going to show it visually here. The ultimate target of a project is like paper PDF, right? This is the ultimate target. This is what every researcher wants to achieve. So then this has two dependencies, paper.tech, this is the LaTeX sources. And then these actually come from this project.tech, which is the list of all of those macros that come from the analysis. Because the reproducibility is not just about the plots, it's also about these numbers that go into the text. And then they get automatically verified with checksums. And okay, so then over here, like this gives a version to the data set. And like over here, this is the data that went into the plot. So this is the data, and then we had to actually get it from the converted format of the release data set by Menke. And over here, like you can see, the inputs.conf has the URL and the checksum of the inputs that are checked. And then like over here, we want to report the URL in the paper. And over here, like we want to report how many like journals they studied and so on. So you see, this is the full data lineage, how we got to paper PDF from inputs.conf. Right? And like this is the one other parameter that we had to give. And you can easily scale this up to actually extend everywhere. And now you see, so we're actually able to give a full answer to each one of these important points without necessarily extending the paper, because all of these things get published with the paper. And because they're in plain text, we can actually do version control. So for example, this is how Maneage actually works. It's actually a full branch, it's a Git branch, and it actually keeps a snapshot of the history as the project goes. So you see the project actually, you actually create a branch to start your project, then you develop your project, and then you can always merge in to improve the low-level infrastructure. But the great thing is that when you publish your paper, this git commit hash actually gets printed automatically onto your paper. And you can actually nicely develop your paper as like, for example, it's undergoing referee reports, and later other people can also build upon it. Like these are two papers, and this is actually, we've decided this convention of having this code at the end of the paper. And the whole thing is easily publishable. So for example, and it's just plain text. So what we do is that we upload it to archive with the paper. So for example, you can go to these archive links, and if you download, I can actually go here. And if you download these other formats, you can actually see the all of this metadata is actually uploaded to archive with the paper. And we also put it on, for example, Zenodo. For example, over here, I'm showing a Zenodo link to this individual paper, and you can see we've actually put the full Git history, all the software needed, the data sets, and everything actually get published together, and we have a full checklist that enables easily doing this. From a research or repository point of view, it's really easy to implement. You just clone the project and you run it like these commands. And so I'll just conclude with some future prospects that it really enables easy understanding, easy easy education, easy testing. And when implemented on a large scale, we can even apply things like machine learning on like thousands of papers, for example, about the evolution of some kind of cell, to be able to automatically generate workflows. And of course, extract data provenance and do meta research, which is done here. Okay, so I'll just leave it on the summary slide. These slides are available in this link here, and there's a longer version also available in this bottom link. And I'll leave it on this slide in case there's any questions. Thank you very much.
Thank you very much for the very detailed presentation, Mohammad. We do actually, so again, please type in your questions, and while you are presenting, we did receive a question from Valerie Veronica Tusubiram. I hope I've read that name correctly. She would like to know how best would one go about database verification.
About data, well, this is about my talk, or yes.
Yes.
So for database, so this is for individual data sets, because like in one research, you can have data from many separate repositories. What we do, I'll just go back in the slides. is where was the okay? What we do is that we check we have the URL or PID. Well, it depends on the database if they have a PID service. Like over here, we're using the Hubble Space Telescope datasets, and they just recently added PIDs, DOI, to the datasets. Yeah, in this paper that was last year, it still wasn't implemented. And so that's one aspect, that you can actually have the URL here. And also we check the checksum. So we take the MD5 checksum of the dataset and of each dataset. And before using the data in the project, we actually calculate this checksum and compare with this string of 40 characters and numbers. And if they correspond, the analysis continues. If they differ, like the URL has been wrong, or it's an updated version of the URL or something of the dataset, then the project is going to stop. And it's not going to continue, and it's going to tell you, be careful, the data set has changed.
Okay, thank you very much for that. Valerie, do let us know if that answers your question. There are two additional questions. So one is from Ryan O'Connor. He's asking you if you can give us more detail on the types of input you had from those outside your own astrophysics domain in this template development.
Mm-hmm. Yes. So one thing, even for astrophysicists, things like Git are unfortunately not too well recognized in a larger community outside, like my immediate, the researchers. That was a big problem, like getting researchers to actually think in terms of version control. It's astonishing that how many researchers, and we actually, I mean, for me, I've been using it for 5 years, and I thought everyone is. But after this grant, and then after actually having a few workshops and things, I found out that many researchers don't even know what Git is or version control. And well, they spend so much time for keeping backups of their files without the structured history keeping like this. And that really affects them. So it was really interesting after we had this excuse of this adoption grant and the workshops and the seminars. Many, especially early career researchers, were really interested in learning it, and they already learned it, and now they're implementing it. So hopefully in the next few months, or maybe during the next year, papers will come out, hopefully using this more. And yeah, this was the main problem we encountered. That Git, the command line, even later, surprisingly, is not too commonly used. Unfortunately, many journals have even moved to Microsoft Word and you can't do these things with Microsoft Word. When you write something, it's like the final version. Yeah, so these kinds of things were the difficulties we encountered, and we're trying to put more workshops, more educational points to get researchers into doing their things more systematically.
That is also, I think, the answer to the next question that we received from Andrew Cholor, who was actually thinking if this would be asking if this would be fitted. How would this work for non-astronomers who are less comfortable with the command line? But that's
exactly
that's exactly
yes.
what you have.
Yes,
I don't
exactly.
know, Andrew, in case, I'll try to unmute you in case you might want to add anything to that question. Let us know if you can speak, and if you would like to add anything to that.
Yeah, but I'm really happy to say that, like, especially from biophysics and biology, recently we've had many, after the workshops, thanks to the RDA grant, several teams are now starting to use it, and they're actually learning these Git and command line and LaTeX and these things. And so far, I'm getting really positive feedback. Now, I am biased because, yeah, I guess if they're not happy with it, they don't tell me. But yeah. So far, those people that have told me have really given positive feedback, because it really helps in their research. They unfortunately, because data carpentry, let's say, is not well educated by the researchers, is not well taught to the researchers. They don't know these things. So having a framework, we're not just teaching Git, we're not just teaching command line, we're not just teaching LaTeX. We're putting them all together into one package that they can learn them in an integrated environment, as the RDA output suggested. And I feel this is one really positive thing, because like if you just search learning Git, you're going to get an abstract tutorial, that doesn't really fit your own research, and you'll think, okay, what does this have to do with my paper and my research? But over here, you see they're all integrated into one solution. And what we've seen is that people actually don't have to learn Git fully. They just learn 2 commands. They start with those, then they learn some LaTeX, then they improve their Git, they learn some make, they learn some command line, then they improve their Git again, And I think this way of approaching the problem has helped.
Thank you very much, and thank you for mentioning several times the fact that working under the RDA umbrella and under the adoption grants that have been made available has helped with especially the dissemination and the awareness raising around that. So if anyone would like to learn more about these adoption grants and the stories behind that, there's a lot of information on the RDA website, and we also have different things, different opportunities that are related to the adoption efforts. And I'll just highlight 2 things. So if you do have, if you're interested in adopting, and if you have a story around adopting any of the RDA solutions, we have ways of getting in touch and helping you tell your story about that, and of course improving via the conversation and the forum that RDA offers. So there's a link on the slides that I'm sharing now. Please join us in talking more about the RDA recommendations and outputs. There's also the option of the CoData call for papers. There's a call going out, and it has been open for a while now, and RDA is supporting through its European project. It's supporting the specific collection, a special collection that is dedicated to the RDA outputs and results, and it includes, you can go forward with adoption stories or different things that you can submit different things that you have done around the RDA recommendations and outputs. And as I mentioned, the European project is available to support the costs of the article processing fees. The deadline for this call for paper and for this opportunity of taking advantage of the support for the publication fees is the 17th of July. So we have just gone a little bit over the time that we have had for the session, but we thank you very much for joining. And again, please feel free to get in touch with us by questions on the RDA website, through the conversations on social media, and as well ask your questions directly to the RDA Secretariat. So thank you very much to our speakers for their excellent presentations today and for your questions. And we hope to see you as well in the session later on today and tomorrow as part of the Adoption Week. Thank you very much again.
Thank you.
Thank you.
Thank you.